the functions given above determine g of 1/3. A lot of times people might see the question and then they started to feel funny. They ask for g of 1/3. No need to feel funny about 1/3. That's fine. We're going to take the g function just the same like what we're doing just now. Let's write what a g function is. G of x is 3x minus 1. We're supposed to be doing g of 1/3. So g of 1/3 is 3 times x, but now you're going to be putting 1/3 where the x is. So it's going to go times 1/3 because 3x means 3 times x, right? So let us use another color pen to put back what was there. There was a -1 at the back, right? All right, so let's go. So here it is. You will notice that this 3 and the 3 here, they could cancel. 3 into itself, 1. 3 into itself, 1. So then we have 1 times 1 is 1 minus 1. And then you get a 0. So g of 1/3 is 0. So let us find, we need to know what the inverse of the f is right now. We don't know it. But the moment we know it, we are going to put this number in it. And the question is solved. So let us find that inverse of f. The f function I will now put on screen for us. It says f of x is equal to 5x plus 7. So that is the f function. Now, in order to do the inverse, we're going to switch out the f of x for y. Because the inverse is about x and y switching places. So we're going to write y is equal to 5x plus 7. F of x equal y. You can tell them that. So in other words, you're saying let f of x be y so you can see where you switch out x, f of x and y. Why are we doing it is because the inverse of a function deals with x and y coordinates. So now you're going to switch. First move, switch x and y. Step 1. Let's switch. X is now equal to 5y plus 7. The second move when you switch x and y is that you want to let y be alone. The proper mathematical term is to transpose for y. So now you want y to be sitting alone. So what are we going to do? Ordinary work. Let us subtract 7 from both sides first. So we're going to subtract 7 there. Balance the equation by subtracting 7 from the other side. Let us write down what we have. At this time, we have x minus 7, which is now equal to 5y. Because this part is now 0. It's gone. So we don't need to write back 0 around there. 7 minus 7 becomes a 0. We continue to work. The y needs to be alone, but y is being multiplied by 5. To get rid of the 5, you divide by 5. It's called inverse operation. 5 into itself, cancel. Balancing, divide the other side by 5. Let's rewrite what we have. X minus 7 over 5 is equal to y. But am I going to write y? No, I don't need y anymore. This is called the inverse of the function. All right, that's now the inverse. So now let's take our time and rewrite it right here. The inverse of f of x is x minus 7 over 5. Inverse. So now they said to you, remember that you're supposed to find the inverse of f of -3. Well, we're going to take -3 and you're going to put it in the same function. It looks like -2 is the answer. Confirmation from anybody who feels secure that this is correct.
Yes, sir.
Yes, sir.
Very good going, everybody. We're doing the f of a half. So you're going to write the f function. Here's the f function. The f function says that f of x is 2x minus 1. That's f of x. So if you're supposed to be finding f of a half, then we're going to be putting a half where the x is. But we want to understand the algebra here. It means 2 times x. So then it means then what we're going to do is 2 times the replacement of x, which is 2 times a half. And you want to write back that minus 1 at the back. What we actually did was replace the x with a half right there. Canceling can take place. 2 into itself 1, 2 into itself 1. So we actually have 1 times 1, 1 minus 1. It is an exact workout like the June. This January is exact like June. You just that they have 3x and now it's 2x. So everybody, you got 0?
Yes, sir.
All right. We're jumping at the second one now, which is h of 0. H of 0 is one of the simplest one because the h of x is 5 raised to the power of x. So h of 0 is 5 raised to the power of 0. In this same class, we had discussed that anything raised to the 0 power is 1. The square of g of negative 3. But I want to highlight for you what the square of a function means, because people think they're going to multiply it by itself. Everything has its own context. In the context of function, watch this. G square of x really means g of x. Everybody, firstly, you need to know what the g function is, right? Let me go back on my document. I just lost it.
Sir, it's 3x plus 2.
Okay, so g of x is 3x plus 2. So now, what we're doing now is, in order to do the square of g first, because we need this first, you need this. This is the same thing as that. So it's a knowledge thing you need to know. So we're saying we need it. So let's go for it. We're going to put the g inside the g. Watch. This is the g. There is an x there and plus 2. But I'm not going to put x because I'm going to put the g function in there. So let me create space for myself so you could see what I'm putting there. I'm going to put the g function, then I have plus 2. So x would have been here, and that's g function, but no longer x because I'm putting the function in itself. Watch. I want another color, red. So you put in the g function in itself. That's all. I remember, you know, it's only one place it can go. A function only, you can only put something where x is. You have to remember that. Can't go anywhere else. You only can go where x is. So now, what we're doing now, let me continue, is that you have 3, and then now you're going to represent the g function. Let me put it, the g function is 3x plus 2. See there, the function go into itself, guys. Don't feel funny. This is the square. This is what they mean by the square. This, what we're doing here, is the square. Let me just put back the square here so that when you're ready to look at it, this is the square. That. This is what it means. I'm showing you. So there it is. So we're having that now. So all you have to do is to carry out the duty. 3 times 3, 9 with an x. 3 times 2, 6. And there's a 2 at the back. Finalize it. 9x plus 8. This is this. Now I'm going to turn it back into what they had started so you can see it. So the square of g of x is 9x plus 8. Vangel, go with your question.
Sir, where did you get 2 2s from?
I didn't say 2 2s. Where did you hear 2 2s? I said 2 3s.
There's one in the bracket and one outside of bracket.
Oh, the other 2 was not mine. Let me show you. the g function has a plus 2 at the back. Can you see it?
Yes, sir.
So this was already there. Agree?
Yes,
The
sir.
plus. Remember that all you're doing now, you're gonna put the g function where x is. So then you could see why I put g of x right there. X would have been there, but I'm going to put g there. And everything else you have to write back. So I would have written back the 3 in front, and then I have to write back the plus 2 at the back because I can't touch those. Talk to me. Vangel, go ahead, man. I know if you're with me right there.
No, sir.
All right, let me see if I can use a highlighter. This and this, you can't touch those. Right? This is what you're putting where the x is. Tell me if you see that. Look, I'm going to put it at the side again. There's a 3x plus 2. You can only put something where x is, like there. So then, you're supposed to write back the 3, but you know that you're putting g here, so you're going to write g beside it. But guess what? This is maths. We can't just write it beside it. We have to show, say, it in our stuff, like me box it up. Then I put back the plus 2. Can you see what I'm saying now? I only could put the g function.
Yes, sir. I think
So you
I
have to write.
understand now.
All right. Then now, you're going to have to express the g function for what it is. You would know that the g function is 3x plus 2. You see it now? But there was another plus 2 hanging outside. It's still out there. This one is
Yes,
just
sir.
the one that went inside the bracket. And then now you do your law of distribution. 3 times 3x, 9x. 3 times 2, 6. So we are right here. And then you simplify. Tell me if you're good now.
Yes, sir.
So that's what we had over the other side. It is there just the same. Just re-explain. So you could write it off. All right. So let us finalize the question. So now that we have the square of g, now they want us to do the square of g of -3. Let me write the -3 proper. Which means all you're going to do is to put -3 in the g function. And there's only one place you can put it, where the x is. Hence, 9x becomes 9 times 3, which is -3, should say, -27. And you're adding 8, and I think you're going to get -19. So the square of g of -3 is -19. We're doing g of f, right? So you want to write what you're about to do, just have a visual. So we're doing g of f of x. That's what we want to do. So the question is, how do you do this? All right, you do this by first understanding that the f function, I will highlight in yellow, will take itself up, and you're going to put this function in the g. You're going to do that. So let us write the g function, because something is about to go in the g function. Let's write the g function. G of x is 3x plus 2. So now you're going to write what we're about to execute. We're going to execute g of f. Of f. So that means I'm going to be putting that right in there, and I still put back that. Right? So I'm going to take it up, that f function. So before I even write the real thing, I'm putting the lettering in there so we could feel comfortable. So now you could see the f function inside the g. And then now what you want to do is to continue doing your algebra. What is the f function? It is 2x minus 1. So let me pick a red for it. 2x minus 1. So you're looking at the f function inside the belly of the g. But it's our responsibility to execute properly. So what we're going to do is to distribute 3 times 2x, 3 times -1, So that gives 6x minus 3 plus 2. And finally, it is 6x minus 1. So if you want to write, you could say, guess what? G of f of x is 6x minus 1. Find the inverse of g of x. I want you to do this one. Where's the g function? 3x minus, oh, you guys did it already. 3x plus 2. All right, so the g function is 3x plus 2. All right, so in order to do it, what we're going to do, we're going to say let g of x equal y. All right, if you want to write mathematical statements such that, and then you could write y is now equal to 3x plus 2. This is like you're writing a book. Let g of x equal y such that y is now equal to 3x. It was g of x equal to 3x plus 1 plus 2, but now you're saying y equal that. Then you switch x and y. So you start the process, switch them. X is equal to 3y plus 2. And then you start transposing for y. So you're seeing that you will subtract 2 from both sides. Let me put it up there. X minus 2 is now equal to 3y. And then you're going to divide by 3, and you divide by 3. And finally, you have x minus 2 over 3 equal to y. But you would have known that they didn't ask you for y. They asked you for the inverse of g of x. So you're going to say the inverse of g of x is x minus 2 over 3. Determine the value of x. Oh, determine the value of x. Can you read that? Is it clear? Answer otherwise. Determine the value of x when the inverse of g of x equal 4. All right. So the inverse of g of x equal 4. Let the inverse of it equal 4. Let the inverse, let me see if we work out the 4 by 6. Okay. So let the inverse of g of x equal 4. What is the inverse of g of x? Let us write it. This is the inverse of g of x. X minus 2 over 3. Let this equal 4 if you're going to do, because the question said the inverse of g of x must be 4. You find x, so you put it. So the inverse, therefore, inverse of g of x. This is the inverse of g of x I'm writing. You're looking at it right there. Let it equal to 4. And then now, as I said, you're solving for x, you know. Of course. So in this case, regular solving. Multiply both sides. Now this will cancel on the left side. So you have x minus 2, which is equal to 12. And then now you will add 2 to both sides. So x is now equal to 14.